Our house is burning. We are looking away. More than 23 years after Jacques warned the world about the state of our planet, we are still looking away. Today, the whole world is watching message reaching out way to the moon. And honestly, so am I as a young scientist. I am fascinated by how far the humanity can go. But what's the point of dreaming about other planets if our own is becoming harder to live on? No matter how advanced our tech gets, we all breathe the same air. Don't get me wrong, I am not saying we should stop space explorations, but here on Earth we have huge problems: climate change, air pollution, environmental disasters, and one day we'll only enjoy those discoveries if we're still healthy here down. I am a PhD student in MC Lahti. I work on air pollution forecasting in atmospheric chemistry. Let me show you what pollution actually is. Air pollution comes from everywhere. Some of it is natural, volcanoes, dust, plants, but most of it comes from us. Industry, traffic, power plants, burning oil, coal, gas. In some big cities, like here in India, you can literally see it. The sky stays gray. Millions of people breathing toxic air every single day. And yet what we see is only a small part of the problem. Here, a massive cloud of smoke from an oil field that was bombed. Tons of toxic particles released into the air. Sometimes it even caused black rain. Since you would accept from a post-apocalyptic show like the 100 movies series. Except this isn't fiction. Some think here bombing of a gas and oil cities. Every explosion releases ultrafine particles and toxic compounds that can travel thousands of kilometers. And the problem with air is that it has no borders. So what's actually in this polluted air, and why are some particles way more dangerous than others? You have probably heard of PM10 and PM2.5. PM2.5 is what we call a mass-based metric, measured in micrograms per cubic meter. It gives you the total mass of all particles smaller than 2.5 micrometers, but it doesn't tell you anything about how that mass is distributed across sizes. It's a bit like a bag of chips. You know the total weight of the package, but inside you have pieces of very different sizes. Some large, some tiny crumbs at the bottom. Two bags can show this exact same weight while having completely different structures inside. It's the same in the atmosphere. Two cities with two same PM2.5 can have a very different particle size distribution, and therefore potentially very different health impacts. That's why ultrafine particles under 100 nanometers matter so much. They contribute almost nothing to the total mass, but they are extremely numerous, highly reactive, and they can penetrate deep in the respiratory system and interact strongly with the body. To put numbers on it, a human hair is 70 micrometers wide. PM10 is 7 times thinner. PM2.5 is 30 times thinner, and ultrafine UFTs are the size of a flu virus, and the smaller the particle, the more dangerous it gets. PM10s get stopped in the nose. PM2.5 reach the bottom of your lungs, but ultrafine, they cross into your blood, they reach the brain. They haven't even been found in placenta of pregnant women. And here's the wild part: some of those tiny particles aren't even emitted directly. They actually form in the air from gases. Picture the exhaust coming out of a car, factory, or fire. Most of that comes out is invisible. Gases like sulfur dioxide, nitrogen oxides, and volatile organic compounds. In the atmosphere, sunlight and oxidant transform those gases into heavy vapors. When there is enough vapor, a few molecules stick together and form a tiny cluster. That's nucleations, and new particles has just been born, only 1 nanometer wide. then more molecules attach to its surface. That's condensation. The particles grew, and when particles bump into each other, they fuse. We have the coagulations now. So above every rod, every fire, new particles are being born and growing right now. As we speak, look at the wildfire in the United States. The whole city is covered in toxic smoke. Animals getting lost. Thousands of birds robbing died in valley after extreme heat and smoke. Air pollution kills more than 7 million people every year, and most of it is invisible. That's why forecasting matters. Pollution moves pushed by wind, blocked by mountain, trapped in valley. Sometimes just a few hours of warning can protect millions of people. That's exactly what I work on. I built an AI model called TopofLaw. The idea is simple. Pollution doesn't move randomly. The shape of the land channels it, wind carries it. TopofLaw combines AI with atmospheric physics to forecast air quality better. If you are interested in TopofLaw and the AI side, specifically let me know and follow us to have all our news. As Saint-Exupéry says, once wrote in The Little Prince, what is essential is invisible to the eye. And that's exactly what air pollution is. Science is how we make it visible. Air doesn't recognize borders. Air pollution isn't just a scientific problem, it's shared responsibility. Because in the end, we all share the same sky.